Dear student, in this session we will discuss the subtopic 3.1 process from unit number 3 process management. The course outcome for unit number 3 is you will able to execute the process commands for performing process management operations, and the learning outcome for this particular subsection is you will able to explain the function carried out in a given process state. The content we are going to cover in this subsection are the process states and the process control block. Now let us see the basic concept of the process. When the operating system executes varieties of programs, the programs may be in the batch system, we used to call it as a jobs. In the time shared system, we used to call it as a user programs or the task. So whenever the program is in execution, we used to call it as a process. So execution of processes must progress in the sequential fashion or sequential manner. Basically, the process it consists of multiple parts. The first part, that is the program code, also called as a text section, which includes the program counter, processor registers. Then another section is the stack section, which contains the temporary data, that is the function parameters, return addresses and the local variables. The third section is the data section containing the global variables. The last section is the heap section containing memory dynamically allocated during the runtime. Now, whenever the process or the program that is available onto the secondary storage device or onto the disk, say for example any executable file, then that particular is called as a passive entity. Now, whenever the executable file or the program is brought in or loaded into memory, then that particular program becomes the process and we used to call it as a active entity. The execution of program started in GUI system by using the mouse clicks or in the command line by simply entering the name of the file and executing it onto the command prompt. One program can have several processes which get executed one after the another. Now let us see how the process looks into the memory. So these are the different sections that are available in main memory related to the process. The first is the text section, which includes the compiled program, which is read from the non-volatile storage when the program is launched. It also includes the current activity, which are represented by the program counter, and it contains the contents of the processor registers. The another section is called as a data section. So data section, it stores all the global and the static variables, and these are allocated and initialized prior to executing the main function or the main program. The third section is the heap section. This particular is used to store the memory dynamically, and it is managed via certain system calls like new and the malloc system calls, which are used for allocating the memory dynamically, delete and the free system calls, which are used for deallocating the memory dynamically. So here we can see that this particular area is varying So whenever the program get executed at runtime, the inputs or the data, whatever we give for computation, further computation, that data will get added into the memory. So the memories is varying over here. The last section is the stack section, which contains the temporary data such as the function parameters, the return values and the local variables. So the scope of these variables are limited till the subroutines or the function in which they were used. So the space on the stack is reserved for local variables when they are declared, and the space is freed up when the variable goes out of scope. That means if some sort of variables we are using locally, so at the end of the function, these variables or the scope of the variable goes over there, and thus the memory is freed, or those variables will be removed from the memory. Now let us see the process state. So once the process is in execution, it has several states, or it may changes its state. So as soon as the new process is created, the state we used to call it as a new. Now once the process is created, it will be admitted into the ready queue, and it is ready for executing by the CPU. So the process is waiting to be assigned to a processor is called as a ready state. Now once the process is assigned to CPU and the process get executed, then the state we use to call it as a running state. So instruction that is being executed or executing by the CPU is the running state. Now once the process is in running state, due to some IO related work or interrupt occur, or the child process birth, the process has to wait. So the another state is the waiting state. So here, after completion of the IO or the interrupt related event, the process will again goes to the ready state. Once the execution of process get completed, then the process get terminated or finished. So the state is called as the terminated state. So these are different states related to the process when the process is under execution into the memory. Now let us discuss the process control block. Each process is represented in the operating system by the process control block. It is also called as a task control block. So different information that is related to the PCB is the process state. The state may be the new, ready, running, waiting, halted or so on. So this is the process state. Then we have the program counter. The counter indicates the address of next instruction to be executed by the process. So this is the program counter. Then we have the CPU registers. So the registers vary in its number and time depending upon the computer architecture. The register may include accumulators, index registers, then stack pointers and general purpose registers, plus any conditional code information. Also, along with the program counter, this state information must be saved in it so that once the interrupt occur and the process again want to continue, this information will be helpful. Then the CPU scheduling information. So this includes the process priority, pointers to scheduling queues, and any other scheduling parameters. So the details we will see in the next unit. Then in memory management information, it includes the information as the value of base and limit registers, then the page table and the segment table all depends on to the memory system used by the operating system. Then the accounting information, it includes how much amount of CPU has been used by the processes, then the time limits, then the start time of the execution of the process, then the account numbers, then the job or the process numbers, and so on. So all the information related to process is available in or here. Then next is the IO status information. This information includes the list of IO devices allocated to the process and the list of open files and so on. So whatever the different IO devices the process is going to use or the process has allocated, all the details as well as whatever the different files that required or needed by the process, the list we will able to get over here in the IO status information. Now, whenever the process switches from one process to another, that means when the context switch is there, then the state is required to or the state information is required to save. So this can be seen over here in the diagram. So say for example we have process P0 and process P1 in main memory, and here at this particular location process P0 is executing. So whenever process P0 is executing, once the execution of process P0 gets stopped over here, then it is expected that the contents or the state of process P0 must save into PCB0. Later on, whenever we want to execute process P1, at that time the state from PCB1 is loaded and the execution of process P1 get started. So this is how from this particular location to this process P0 is in execution mode. Now due to some reason when process P1 want to stop execution, so again the state of process P1 is saved in PCB1, and then later on if we want to continue execution of process P0, the contents or the state from PCB0 of process P0 is reloaded and the execution of P0 get started. So in this way, whenever we switch from one process to another, the information or the state of the process is saved into the PCBs of respective processes. So this is how we discuss in this session the basic concept of the process, how the process is in memory, then the different states of the processes, that is new, ready, waiting, running, and the terminate state, and the PCB block which contains various parameters, that is the process state, program counter, CPU registers, CPU scheduling information, memory management information, accounting information, and the IO status information. So this is all about the process. Thank you.